Hello, friends. The stars can go very, very large. They can grow very large. And, our planet is revolving around sun, which is a mediocre star. It is a yellow type star, which is mediocre. And there are very few. But then even fewer are the larger stars like supergiants, giants, and even hypergiant. So we are going to discuss something about UY Scuti, which is the largest star ever found, and this is actually found in our own galaxy. So we have done a lot of study, and this is something that I thought I will bring it to you. It's very astonishing to know about such a huge structure, such a huge body in our own galaxy. So let's move on and examine this up close. Well, UY Scuti is so large, it is actually coming into the category of hypergiant, and its radius is 1700 times larger than that of our sun. So if you want to basically examine this star, it is 1700 times bigger than our sun. You can imagine how big this star would be, and it is in our own galaxy. And what kind of environment this star must be creating. Now, just to give you a perspective, this is the a portion of UY Scuti, and this little dot is our sun. This is the size difference between UY Scuti, which is the largest star we have been able to locate, and our sun. So our sun and the entire solar system looks so small in front of this large star. And if you want to further compare the size of UY Scuti, nearly 5 billion suns can fit into the volume of this the shape of this particular star system. So it is huge, it is astonishingly huge, it is astonishingly powerful. And I mean, if you look at the brightness, it burns very, very hard and produce a lot of light, lot of different kinds of radiation and different types of light. And since it's a very, very large star, it produces a lot of heavier elements. Well, sun also produces heavier elements, but it does not produce a lot of elements. I mean, it burns hydrogen, then turn into helium, then helium burns into other elements, and probably it will stop at carbon. That is the limit of sun. Whereas this star can produce even more elements during its life cycle, and this is also a variable star because it actually fluctuates in terms of size, because the star is so huge and the core may be also very, very big. And because of that, sometimes it produces more energy, sometimes it produces less energy, and based on the amount of energy it produces, more kinetic energy is available, and that balances the gravity. So when the star is not producing a lot of energy, it will shrink a little bit, and when it is producing more energy, it will expand a little bit. So this is a variable star. And we've also calculated that this variable has a frequency, and it is of 740 days, and it basically shrinks a little bit, and the shrinking will bring more intense reaction at the core, and because of this intense reaction, the gravity will basically be balanced. So this is a very peculiar characteristic of UY Scuti star system. And where it is located, it is actually not very far off. It is only 9,500 light years away from Earth, but it is towards the center. It is actually much closer to the center of the Milky Way, much closer to the Sagittarius A star, our own black hole, and it rotates around it. So it is not very far off from Earth, but it is quite far. I mean, it is far that it will not have any impact on Earth. So we can still use very sensitive instruments and see this large star and its effect on the surroundings. Well, in terms of its burning, because it burns very hard and it's very, very bright, and that is why it is hypergiant. It is falling into a category of hypergiant. and throughout its life it will burn brightly, and it also create a lot of solar wind which keep escaping, along with the energy. So it lose a lot of its mass throughout its life, and it creates a lot of fast stellar winds. So that is another thing which is very peculiar around this. And because of this huge stellar winds, the chances are there will be no planets, there will be no material available to form planets, because the wind velocity will be so high that none of the material will remain there in the orbit to basically stick around and eventually form planets. So this star is creating a huge stellar storm all the time and burning very rapidly, very fast. Now if you want to compare further and you bring this star into our own solar system, replace our sun with UY Scuti, this photosphere of the star, which is the outer layer of the star, any star, will be as big as the orbit of the Jupiter. You can actually see in this picture, how big the star is, and the solar wind will actually will be felt beyond the orbit of Pluto. Well, Pluto is so far off from there, the sun looks like any other star. So you can imagine this star, UY Scuti, is so big. And just to compare, if we just compare with our solar system is tiny in front of the star in terms of, shape and the size. Well, UY Scuti will continue to burn harder and faster. Friends, you must be knowing that the bigger stars basically have very small life, because they burn everything quickly, and once they burn, the gravity basically takes over at some point in the later years of their life, and then the whole thing explodes into a supernova or a hypernova depending on the size of the star. So UY Scuti will will last for 10 million years, and then it will explode in a huge supernova explosion, spreading all the material that it has formed over 10 million years, all the heavier elements like iron and other things, spread across into a very big nebula. And what will remain after this huge explosion will be either a neutron star or a black hole. This neutron star and black hole will be the core of the UY Scuti, and neutron star will spin very rapidly and will prevent it to fall further into a black hole. But it's very difficult to say what it will form at the end of its life cycle. It could be a neutron star, it could be a black hole also. So this is something very, very interesting, and I thought I'll talk about it in this edition of Multiverse and talk about this astonishing large object in our galaxy. It is huge star, from all angles, from all characteristics in terms of material which is available, etc. It is mind-boggling. So friends, if you know more than what I have told you in this video, do send in your comments, and thanks for watching. As always, I will catch you again in the next edition of Multiverse.